Hello, welcome back to 14 Minesweeper variants. Yes, okay, so last episode we did like a bunch of plus puzzles. This one, I don't think we finished all 10, so I just did the remaining in my own. I got 10 out of 10. And because we finished 10 of each variant combination size, we also unlocked each of the combos. Combos? Yeah, each of the combos. Whoa. Yeah, we also got some really special combination puzzles here, but we will look at that next time, I think. But now we've unlocked the gallery. What's next? Well, we have a new symbol, and that new symbol is the attachment rule, which I guess also starts with A, I guess. A right side rule is combined with a secondary board. So we know that secondary boards exist in the E and L variant, and so N adds this E and L to another one of these variants on the right side, whereas plus usually just adds E and L to the left side variants. So we'll get this cross with E and L. We'll get deviation or product or modulo or area with E and L as well. So I think that'll be pretty interesting. And also clearing all of these gives us some very interesting stuff. 10 levels of and 8 times 8 to unlock and apostrophe, which is a different way of the and, I guess. Plus and and together gives you plus and together, I guess, which is really interesting. And will also unlock 2 hashtag, which, because plus is not 2 plus, so it's the same, it's just 2 random rules are combined. I'm thinking that 2 hashtag might be different than regular hashtag, otherwise they would just give it a regular hashtag. But we'll see. Alright, so let's start with and. Oh my goodness. Alright, can you actually see the letters here? I hope you can. If not, I can like contrast it a bit. Give it a higher visibility. There you go. That probably works. Yeah, way better. Okay, so encryption and cross. Alright. Encrypted means that numbers are hidden behind letters or variables, and each letter refers to a single number. Each number is covered by a single letter, and there is a one-to-one pairing, so no repeats, every number is used, every letter is used. Alright, so cross. I should probably explain all of these as I go along. I think we're early enough in the series where I still get to explain all the rules. Cross clues have 2 numbers in them, and each number refers to the number of mines in one of the 2 colors around it. So you have light and dark mines here. The 1, 3 could either mean 1 light and 3 dark, as in this case, or 1 dark and 3 light, as in this case, and that goes for every single clue. But each number is clearly for different. Each number is hidden by a different letter. Alright, so let's start with the logic here. I think logic goes pretty similarly to regular encrypted for cross. For deviation as well, should be pretty similar. When we get to modulo and area and product, yeah, those will be pretty interesting. Alright, anyway, so AA means that there are an equal number of dark mines as light mines, but we know there can only ever be 0 or 1 light mine, because you can't put 2 or more light mines in this cell alone. And so what that means is that A must be at most a 1. You can't have A be 2, otherwise you need 2 light mines or more. So A can't be 2 or more. And I guess we could probably do the same thing here. In fact, this might be an interesting combination that we might have to look at. Or maybe D and E. Well, I guess D and E neither can be 4 either. Yeah, D and E can't be 4 either. I think C works similarly. Yeah, C can't be 4. See, none of these colors have 4 cells around it that work, which means that B has to be 4. How about B doesn't exist yet, so if B ever existed, that'd be actually like really trivial to figure out. Yeah, but we'll see. Okay, what else do we have? Well, I want to say that C is more than E. Do the A's here refer to the same thing? It might not actually. Because if A was a 1, for example, this could be 1, 0, and this could be 1, like maybe 2. 1, 0 as well. Or maybe it can't be 1, 1 because they're different values. Let's say 1, 2, which is clearly not possible, but let's just go for that. Because even though A refers to 1 in both cases, you could have A referring to light here, so there's 1 light mine. But this A could perhaps refer to darks, so overall around here there could be 1 dark mine and 2 light mines. Yeah, in fact, this is actually valid. So I just realized, yeah, the A's could refer to different things. Huh. And then the E here is 0 for 0 darks, but the C here is 2 for 2 lights, and the 1 would be for 1 dark. Which is... So the ones have to refer to the same thing. Okay. Oh, wait, hold on. DE and DE, they're the exact same clue. And they do follow the same thing, actually. Yeah, in fact, for DE, one of the values have to be talking about the darks, for this set at least. So let's focus on this set. One of the values have to be talking about the darks. So one of the values have to be a 0 or a 1, right? So either D is 0 or 1 or E is 0 or 1, by the same way we saw that A is 0 or 1. What that means is that if A is 0 or 1, and then either D or E is 0 or 1, that gives you the 2 letters that are 0 and 1. What that then means is that C cannot be 0 and 1 anymore because you have a pair. So by regular encrypted, I guess, that also works. So now C has to be 2 or more. Okay, well, let's try having C be 3. If C was 3, then in either case, E would have to be 2, right? Because A can't be the one that takes up the 2 role, I guess. Yeah, in both cases, either light has 2 touching this clue, or dark has 2 touching this clue. In which case, the E would have to take up the 2 role. I mean, that's valid. Then D could be the one that's a 1 or a 0. But if C was 2... I don't know. Does C have to be... Yes, in fact, C has to be more than E. Yes, and you can sort of prove that by removing A. Because A is the same value, you can think of cross as giving more information than regular Minesweeper. The number of mines around this cell is actually A plus E. Because there are A of one color and E of the other color. To get the total, you just add the 2 colors. And so the total around this cell is A plus E. The total around this cell is A plus C. And the difference between those is if you take this minus this, you get the A's cancel out. And so you only get C minus E. And because there are a non-negative number of mines in this area, C must be at least equal to E. But C can't be equal to E because they must be different values by encrypted. So C has to be at least 1 larger, which means that firstly it has to be at least 1 mine here so that C is larger than E. And also that also means that, well, E, E can't be as high as a 3. Because if E was as high as 3, C would have to be higher, which isn't possible. And I guess we also know that because there is no way you can fit 3 of anything in here, 3 of any color. So E can't be 3. That leaves D or C to be 3. Well, suppose D was 3. Let's see that, because I think that's very restrictive. If D was 3, you'd have a situation that looks like this. And then E could be, I don't know, E could be 1 or 0. C must be 2. And so what would C look at in this case? Well, A has to look at the darks. Okay. I think this fails. Because given that D is 3, we now have this situation which we figured out because D must refer to the one that, the only color that can have 3. A now has to refer to darks for this clue because A can't be 2 or more. And if A refers to dark and already has 1 mine in it, it can't have more mines because it can't be 2 or more. So none of these dark cells are mines. Therefore, because C is 2 and C already sees 2 light mines, this can't be a mine either. That now fails this clue because we know A and E are different values, but they're an equal number of lights and darks. So that fails, which I think generally just means that D can't be 3. So yeah, alright. Which means that the only letter that can be 3 is C. Okay, that was pretty tough. 3A. But that either means this, or I guess changing another color, this. Can you see that? I think is green better? I guess the green is slightly better. So you either have this or this, and in both cases, there will either be 2 lights or 2 darks. And because A is not a 2, E must be 2. So that gives you that. And clearly, E is going to be the one that looks at the bigger color, because there can't be 2 mines in this singular cell. So there's a 2 there and a 2 there. Well, now this works with the AA because there must be only at most 1 here. And if there are already 2 mines in these 3 cells, even if we place the mine here, there has to be at least 1 here. So now we know that A has to be a 1. And so there's 1 light mine here, which means this has to be a mine. Also, there's exactly 1 mine here, but we know that there are 2 mines in the dark cells. And so because there's exactly 1 mine there, there has to be another mine here, and therefore no mine here. Alright, 1, 1 means that this can't be a mine. And there's exactly 1 mine here. Oh, D is just 0. Alright, well, if D is 0, then 0 must refer to this dark cell, so there's no mine here. 0 must refer to this white cell, light cell, so there's no mine here. And I think this is just regular X. So yeah, okay, 1 and 2 gives you 3 total, so there are 3 mines around this clue, which can be easily solved. There is 1 mine in here. And because 3 must refer to dark, it can't refer to light, it must be 3 darks and 1 light. 0, 2 means that has to be a mine. 1, 2 is complete. 2, 3. I don't know. Well, 1, 2 means there can only be a maximum of 1 mine in here, and therefore 2, 3 must have only 1 mine here, and therefore must have 2 mines here. 1 mine here will also complete this 1, 2, so there's no mine there. 0, 1 is complete, this is complete. 1, 1 is complete, this 1 means there's a mine here, and because there's 0 mines remaining from the remaining cell count, there is no mine there. Wow, okay, that is really tough. Oh, yeah, that is really, really tough. Oof. Okay, well, there you go. 2e to x. Next, liar and deviation. Well, deviation is pretty similar to regular Minesweeper compared to like the rest of the right side clues. So it shouldn't be too different. Liar means that every row and column has 1 liar, which is denoted by where the circle is on this board. And wherever that liar is, that value is either 1 more or less than what it actually shows. So this is either a 2 or a 3. So you can see it has 2 mines around it and not 3. This 0 is a 1, so it has 1 mine around it, not 0. Yeah. And deviation really just means that numbers refer to the 3x3 area above it and not around it. So you can see here it's coloring the exact clues, the exact space that it covers. Yeah, alright. So 2L2D should not be too challenging. Let's perhaps start with the 4 and the 0. Yes, if the 0 is true, then there will be no mines here. But that does fail the 4, because even if the 4 was a mine, it can't be any lower than 3. It can only be 1 more or 1 less than its actual value shown. So it's either a 3 or a 5, but clearly you don't have enough space to put 3 mines or more in here. So if this 0 was correct, this 4 would fail no matter what, which fails the whole puzzle. So this 0 must clearly be wrong. Nice, okay. And this 4 I think is also wrong, because this 0 must be a 1, because it's a liar. But this 4 must be a 3. If it were a 4, you would have to put at least 2 mines in this region covering the 0. And that fails, because 0 can only be 1. So this 4 must also be a lie. Nice. And there can only be at most 1 mine here. So this 4 must clearly be a 3, which means that there are 2 mines in here and no mines in here. Nice, alright. Well, this 2 is saying that there are 2 mines here. This 2 could be telling the truth if both of these were mines. Could also be a lie if only one of these are mines. So I think it doesn't really matter there. This 1 is telling the truth though. And we know there's exactly 1 mine here. So there's no mine here. And this 2 is also telling the truth. So there's 2 mines here. But by this 2, there's also 2 mines here. So I think that means that there's no mine here. Cool. And 1, which is telling the truth, means that there is exactly 1 mine here. So for this 2, there must be a 1 mine here, which gives you no mines here. Okay. I mean, this 2 is surprisingly still unknown. Could be telling the truth or lying. This 1 is telling the truth and is complete though. This 0 is clearly lying because it already has 1 mine in it, so that's a lie. Okay. And there's 1 mine here. Well, there's 7 cells remaining, which is interesting. Okay, and here comes a very interesting deduction, a very interesting implication of liar. Because a liar must be a liar, it can't be a mine. And because there is 1 liar in these 2 cells, one of these cells are not mines. One of these cells must be a number that lies. And so there can't be both of these being mines, because then none of these would be liars, and that fails this row. And so that means is if there was one liar here, if you filled the rest with mines, and filled whichever one was not a liar here with a mine, plus a mine here, that would give you 3 plus 3 plus 1, exactly 7. So, by the remaining cell count, which is, like, it's really early to use it, but we have to use it, it just so happens that placing mines in wherever else that you can place it in would give you an exact value of 7. So that must be the case. So you have mines here, 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 and here. One of these are liars, and one of these are liars. One of these are mines, and one of these are mines. What can we figure out from here? I think... If this were if this were a mine, then clearly this must be a liar. Oh, that fails. Because if this was a mine, then that is not a liar, which means this must be a liar in this row. But if this was a liar, it fails because there are exactly 2 mines around it, which makes it tell the truth. That's a paradox. It can't be a liar that's telling the truth. So that means that this can't be a mine. I think that might have been an easier deduction than the 7 mines remaining thing, but it is a lie, which means that this must be a lie and therefore not a mine, which is marked out for us. And 2 mines remaining means those are both mines. Cool. There you go. Okay. 2 liar, 2 deviation. So even with just regular like Minesweeper-esque things, you can do very cool things with liar. Alright, whoa, liar and modulo. Okay, so right now all of these are lies. I assume this asks me that this is wrong, but these 2 are correct, I guess. So yes, this one could either be a 0 or a 2, but modulo here means that the number is actually a mod 3 value. So this 1 is something mod 3. That means it is either a 1, 4, or 7, but it is lying, so its clue is either 0 or 2. If it was 0, it could be a 3, 6, or 9. If it were 2, it could be 2, 5, or 8. Okay, 9 is clearly not possible if you use modulo, but yeah, okay. What I was meaning to say is that this 1 over here, this 1 over here is acting as a 0. So even though there are 3 mines around it, it acts as a 0, which is 0 mod 3. This one could also act as a 2, which has 5 mines around it because 5 is 2 mod 3. But this one, having 4 mines around it, already is correct, so it is not a liar, and therefore this fails. Oh, and this works, but these 2 don't. Why? I mean, this could be a 3, but 3 is not a valid clue in modulo, right? You only have 0, 1, and 2. 3 would already be replaced with 0. Yes, and I think the reason why is because modulo is really defined as dividing by 3 and taking the remainder. And if you divide 3 by 3, you don't get a remainder of 3, you get a remainder of 0. So this value can't actually be 3, which means that this is wrong, because even though this would fulfill liar technically, it fulfills liar in a way that breaks the original rule. So this is wrong, and then this 2 already satisfies itself, so it can't be a liar, which means it's wrong. This 2 though, acts as a 1, which is valid, so this is right. 0 also does this. What? Wait, hold on. Oh no, 0 acts as a 1, which is correct. But 0 can only be a 1. 0 can't be a 2, it can't be a -1 either, because it's not a valid clue. So something like this -1 is technically true here. This is 5 is -1 mod 3. If you look at the math, it is -1 more than a multiple of 3. It is a multiple of 3 minus 1, so it's technically -1 more than 3. But here -1 is not a valid clue, because if you divide by 3, you don't get a remainder of -1. So 0 there is wrong. And then here 0 fulfills itself, so it's also wrong anyway. Okay, so lots of really interesting implications of lie and modulo together. Oh, that's why there's so many clues here. Okay. Well, what is this? What is this code? 5 by 10-10-5. Okay. Geez, where do we start? This 2 I think is a liar because it was telling the truth. It must be, it must have at least 2 empty cells around it. So this 2 is a liar. Okay, and this 2 is a liar, which means it can only be a 1, because it can't be a 3. And being a 1 means there must be a mine here. Okay, 0 is telling the truth, which means it must be either 0, 3, or 6, but it can't be 3 or 6 because there are not enough cells around it, so it must be a 0. This one is telling the truth, so there must be a mine. This one could be telling the truth if this was a mine, and that would cause this to be a liar. Okay. What about this one? I think this one must be this one could be either, based on whether this is a mine or not. If this one is telling a lie, then these are both true. Oh, but mine's here but a mine here would fulfill everything. Yes. Okay. If this one was telling the truth, it must be a 4 because it can't be a 1. That will force this to be right and this to be wrong. So I think in both cases, this is always right. This is always a truth. And because it's a 1, this must be a mine. Okay. Cool. Now one of these are lies, and depending on which is a lie, this is a mine or not. This 2 is telling the truth, which means that this must be a mine to fulfill 2. And this 2 is telling the truth, but it can't be 5 or higher because there are not enough cells, so this must be a regular 2. So one of these are mines. 0, we don't know if it's telling the truth or not. This 1 could also be lying. But suppose it tells the truth, then because it can't be a 4, there's no space around it, these can't be mines. Suppose this 0 is telling the truth. If this 0 is telling the truth, it must see 3. What does that imply? Well, it could be both of these being mines, or it could be both of these being mines, so either way it could evade either this clue or this clue if you need to. If this 0 is lying though, then it must be a 1, because it can't be a -1. But a 1 here could either be a 4 or a 1, and a 4 would do this. A 4 would do that, and that, I mean, that would make this the truth and this a lie, and then this would be fulfilled. Okay, and then this would have to be the truth, which means these are both empty. Does that work? Yeah, and you could put 3 more mines here, and that would give you the 6 remaining mines here. So that works. Whereas if this 0 is telling the truth, then it must see 3, but I don't see how that works. Okay, maybe look at this one instead. Gee, wait, if this 0 is a lie, putting no mines here, is this valid? This 1 would definitely be lying because it sees a mod 0, 0 mod 3. This 2 would be valid. This 1 has to be valid because it can't be a lie, and so none of these are mines. And there are no more. Yeah, there are 6 mines remaining, but there are only 5 cells remaining. So this definitely doesn't work. So if this 0 is lying, it must be a 4, like this. But this 0 could also be telling the truth, which is the problem. If it was telling the truth, that still doesn't mean this must be lying, because it could also be telling the truth and this could be a lie, right? Because you could have a mine here and here. And then, oh, but if this was a lie, then this 1 would also be lying, because this lie can't be a mine, and therefore this one wouldn't see 1 mod 3 number of mines. So this 1 will also be lying, and it gives you 2 lies in the row. So this just can't be a lie, meaning this must either be the truth or it must be a mine. Which means if 0 was telling the truth, then 1 must be lying, because one of these are lies. And does that work? If 1 was lying, it must be either a 0 or a 2. So I think there could be any number of mines here except 0. I think that's fine. I don't know about this though. Okay. Now, this is really tough. Wow. Oh my goodness, N is actually like a way harder thing than usual. N is even harder than plus. Even in the 5x5 stages, it's just really impossible to do already. But if this 0, I still want to figure out if this 0 was a lie. We figured out it can't be just a regular 1. It must be a 1 mod 3, which is a 4. That will give you this. This 1 will be telling the truth, which means these are both empty. And these will all be mines to make up the 6 remaining mines here. This 2 would be lying, and this one will be telling the truth. Yeah, this could be the lie to give you one lie in this row and this column. And I think that just is exactly the correct number of lies, right? No, wait, this one doesn't have a lie. And can't, because you can't have a lie here or here because there already lies in the row. Really? That's the way to do it? None of these are lies. And there can't be lies here either. Because there already lies in the rows. So this particular setup just doesn't work. Which means 0 must be telling the truth? Wow, okay. Jeez. Alright, that is really weird. I mean, what can we do with that though? What can we do with that? I mean, knowing that 0 is the truth means that there are 3 mines total because there can't be 0 mines or 6 mines around it. If we suppose that there are mines here and here, which I think is something we haven't covered yet, then this 2 is complete. This 1, I don't know what's happening to this 1. I mean, this could be the lie for this row. Then this 1 is correct. This 0 is wrong. This 2 is wrong. This 1 we know is wrong, so there has to be some number of mines here. And then you could still have 3 mines here, plus 1 mine here. Or anything else. Yeah, I don't think there's anything wrong with that. I don't know. I mean, we know that one of these has to be mines. Okay. I mean, if this was mine, then these are both non-mines. Then for the 0, these are both mines. And then this 1 is truth. And then this row must have a lie here. And then what? No, and then... Oh, I guess... Wait, no, then one of these could be lies as well, because these could be numbers that are lies. That's valid. Jeez, okay. If here... Yeah, same thing. And these can't both be mine, so the lie is going to be here somewhere. But they could both be empty, I think it's fine. What? I cannot figure this out. Alright, I mean, we haven't seen this 1 properly, I guess. If this 1 is a lie, so if it was a 0, it must be a 3 actually. What does that do? What does that do? Nothing. I mean, it tells you that this isn't a mine, but also nothing else? If this 1 was in fact if this 1 was in fact a 2, then one of these are mines. But what? Whichever's a non-mine doesn't have any restriction. It could be a lie, it could be not a lie. Okay, this 2... Oh, this can't be a mine, because if this is a mine, this is a lie, but this 2 would be a 0, which fails. Oh, so this 2 has to be telling the truth. Wow, okay, it means that's not a mine. Oh, finally, this 0 is telling the truth, which means that has to happen. This 0 is telling the truth, which means that's empty. This 1 is telling a lie, so that has to be a mine. This has to be a lie, this has to be a lie. This 2 is complete, because it's telling the truth, and 3 mines remaining, so I'm not going to bother the rest of the numbers, these are all just mines. Oh, man. Okay, there you go. Oh, my brain just died doing that. But yeah, hopefully that was fun enough. Jeez. Okay, let's see if we can tackle the 6x6. Hopefully our brain just doesn't die from that. Oh wow, we already got an f equals 5 from nothing. Are you sure? Yes, f is just 5. This is giving it to us for free. I guess 1 we could give us for free. Like you've seen, like in an encoded or encrypted, sometimes they're just random x's everywhere. You could give it to us for free if all of these were given x's, then f would just be 5 by value. Okay, well, f being 5 doesn't really do much. Oh, this is 2e2x again, so I guess we're doing the same thing. Alright, fine. B, B, and C, C means that... okay, well, that's something. If B, B, and C, C has to be greater than B, because this sum has to be greater than this sum. So we can say 2C is greater than 2B, divide both sides by 2, you get C is greater than B. But, because C is greater than B, C has to be at least 1 more than B, and that will require 2C to be 2 more than B, and if that's so, both of these have to be mines. And you can't change anything about that. So firstly, both of these are mines. Secondly, C is greater than B. So C can't be 0, B can't be 4. In fact, yeah, we already knew B. Yeah, B in fact can't be greater than 1, so we can do that. C has to be greater, so C can't be 2 or greater. That gives you that. There's more B here. Well, I guess B can't be 0, because one of the B's have to be looking at the light cells, and the light cells can't be 0 anymore, so B is just 1. C is therefore just 2. And because of this 1, 1, there's exactly 1 mine here. Because this 1, 1, there's no mines there. AE, 1E. Well, E can't be another 1, so E has to be 0, because E can't be 2 or greater. Which means, wow, A has to be... Well, A has to be 3, because A can't be 4. Oh, I realized now why nothing can be 5. Wait. Yeah, because there is no way to put 5 in X. There is no way you can have 5 of a color around that cell. So if any clues show up here, it just can't be 5. I think that's why this is pre-given to us. Although I don't think I saw A anywhere here, but that's fine. So again, we know now A has to be 3, and therefore D is 4. 0, 3 means that 3 has to be referring to the light cells, and 0 is here. 1, 1 means that has to be a mine. 1 mine here gives you the all 3 mines to fulfill this 1, 2 clue, which means that isn't a mine. I think I'm rambling, but... Alright, 4. Well, 4 has to be dark, because there are not enough light cells for 4, so these are all mines. That fulfills the 0, 1. This 1, 1 means this is not a mine, that is. 2, 2 means that, well, there are 2 dark cells, so, I almost misclicked. Those are both non-mines. 1, 1 means 1 mine here. So for the 2, one of these are mines, the other one has to be here. 3 has to refer to the dark cells, because the light cells can't be 3. Sorry, because the dark cells can't be 1, so the dark cells have to be 3, which means that is a mine. 1, 3 is fulfilled, so none of those are mines, which means that's a mine. 2, 2 means that's not a mine, one of those are mines. And because there's 1 mine remaining, none of those are mines. And this 2, 4 I think just means that that can't be a mine. There you go. Okay, well this was way easier than the previous level. Maybe I've come up... Yeah, maybe I have like learned something from there, I don't know. Well, I mean, I think that's all the time I have. Okay. Oh, we have Lion. Yeah, we've done this before though. I want to go to like newer variants. I guess I'll do this in my own free time and then I'll like record newer variants, I guess. Yeah, but oh my goodness, N is definitely something. Until then though, I think I'll see you guys next time. Yeah, this is good enough. Alright, I'll see you guys next time. Bye bye.